In this video, we're going to introduce risk and return. Talked about this in many other videos, but we want to get into more detail. We want to dig a little bit deeper into the concepts of risk and return. So one of the things we'll be discussing throughout this video and some in the future here will be what are the sources of return and how is that influenced by different types of risk? Now, as far as risk is concerned, we have macroeconomic fluctuations, things in the economy that change. We have changes in the fortunes of industries, right? Industries mature, industries go away, industries emerge. Firm specific and unexpected developments. Things happen in companies that alter the riskiness, the uncertainty of the future. The return that we want to talk about first here is the holding period return. Fairly simple formula. Holding period return is you take the ending price and add any cash flows over the time period, divide that by the beginning price. Now you take that to an exponent, 1 divided by n, where n represents years. You subtract that from 1, you'll get a decimal. Move the decimal 2 points, and you'll end up with a percent. So let's see how this works. We have a beginning price of 100, ending price is 110, and there's $4 paid in dividends. So if you calculate the return, that's 14%. However, the holding period return represents the annualized return, or more talked about as the effective annual return. So when we calculate this, if we had a 1-year time frame, the return and the holding period return would be equal. That'd be 14%. But what if it took 6 years for this to occur? At 6 years, the 14% is the annual return here. But one way you could kind of think about it, what if you divided it by 6? Divide 14 by 6, get a little bit more than 2. And of course, since we have compounding of money here, 2.21 is the correct average annual percentage earned on this investment. What if it took 6 months? And the return you'd earn more, because not only would you earn this 14% in the first 6 months, you would earn another 14% in the second 6 months, and that would annualize or compound. So 14 times 2 is 28, plus the compounding over that 6-month period gives us the. When we think about continuous compounding, now this is a theoretical construct that says that we are going to compound every instant. And really, this is used most in theory because we don't want to take into account all the variability with time periods. So if we assume continuous compounding, quite frankly, it just makes the math a lot easier when we go to talk about theories. So you can, if you know what the continuous compounding rate is, or what the effective rate is, excuse me, if we say it is 5.75%, what is the continuous compounding rate? 5.59. It's going to be a little bit less than the effective because it's going to compound instantly, so it's going to grow more frequently. And likewise, if you knew the what continuous compounding rate does a firm have to pay if they want to provide a 12% effective rate? Again, that's 12.75% is the effective annual rate that they would receive. What about annualized rates of return? Again, we can do this for lots of different assets. This is just an ongoing example here of what would you do with a zero coupon bond. A zero coupon bond has an ending value of 100 or 1,000, depending on the bond. And in this case, we'll say this bond is selling for 23.3. Takes 25 years for this to happen. It's this example right here. And if we look at this, the rate of return that's not annualized, that's 329.18%. And the HPR that's annualized, if you take annualized into consideration, that's essentially 6% annualized per year. So what are the factors that we have that affect rates of return in general? And essentially, we're talking about inflation for the most part. The supply of funds for savers and primarily households here, certainly how much money you and I have is going to affect the supply of money. The demand for funds from businesses and governments, right? Again, the government's net demand for money certainly is going to drive interest rates. And finally, the fourth piece here is going to be the expected rate of inflation. Now, how this plays into returns, we want to try to talk about how this might affect the numbers, or how can we how can we discuss or include these factors that affect interest? How can we incorporate that into our estimates of what returns should be? Now, the nominal rate of interest is the growth rate of your money. But the real rate of interest is the growth rate of your purchasing power. So, again, we have our R subscript nom for nominal and real for real interest rate. I is the inflation rate. So, if you want to find the real rate of return, take the nominal rate minus inflation and divide that by 1 plus inflation. Now, we can approximate that just by subtracting. So if you take the nominal rate minus inflation, that typically gives you the real rate of return, or at least an approximation of that. Sometimes we also want to incorporate taxes. So again, how can we solve these formulas? So these equations here, they all have to equal, right? So the nominal rate, you multiply that by 1 minus t and subtract inflation. That equals the real rate plus inflation, multiplied by y minus t minus I, which also is what? The real rate times 1 minus t minus I times t. So the after-tax return falls by the tax rate times the inflation rate. The theory that helps us kind of address all this is what's referred to as the Fisher effect. The Fisher equation predicts the nominal rate of interest, and it should track the inflation rate, assuming that the real rate is somewhat stable. Is the real rate stable? Research shows that it does change from time to time, so it's not perfectly fixed, but it does seem to change relatively slowly. Now, this works a lot better if inflation is more predictable, and investors can more accurately gauge the nominal interest rate they require so that they can get an acceptable real rate of return. So that's a pretty long sentence. Basically, look, this works really well if you can predict inflation. What do investors want? Investors want, in the end, although they never talk about it, they want to get a real rate of return that grows and helps them to increase their wealth, measuring by their purchasing power. So the nominal interest rate has to exceed that in order for us to be happy investors. So this concept says what? Interest rates have several parts. A real rate, determined by supply and demand. the inflation premium. Talked about that in a lot of different classes and videos. And the risk premium. Now, this is just the piece that's attached to the characteristics of the asset. So it talks about the liquidity of the asset, marketability, maturity, the company, and the securities attributes in general. So all of these things build into the interest rate or the nominal rate that we see. So if we expand this version, right, here is the formula that we had a second ago to calculate the nominal rate or the real rate. So the real rate, the nominal rate is the real rate plus the real rate times inflation plus inflation. And this is what we refer to as the theoretical value. Now, this particular formula only applies to risk-free investments. You'll notice it doesn't have any risk premiums here. So there is an approximation method that also lets us incorporate risk premiums. It's the real rate plus the inflation premium plus the risk premiums for the asset. Just as an example with this Fisher effect, assume the nominal rate of interest is 5% and inflation is 3%. If we plug that into the Fisher effect, we'll find that the real rate is 1.94%. Now that's the actual rate, right? That's theoretically, that's the correct rate. But sometimes we don't need to be all that accurate, right? We can sometimes use an approximation. And in fact, if we're talking about corporations, as you remember, we talked about that the theoretical version does not include the risk premium. Down below here, we can insert a risk premium to get to be able to use this for corporate types of returns. But again, if you look 5%, 3%, the approximate rate just subtracts, so it's 2%. So what we can see is that these two numbers are usually pretty close, right? I mean, there's not that much of a distinction between the two of them. So again, calculating and trying to understand how interest rates are created, what is their composition, allows us to understand a little bit more about what we're actually getting when we talk about returns, right? Nominal returns are nice, but we need to be concerned about our real returns. Take into account inflation, take into account taxes to understand what our after-tax real rate is. That is the number that we're actually striving for. Look forward to talking to you in the next video.